Welcome to Trikona Skill, your lifetime career partner. Trikona is a pioneer and trailblazer in the field of civil engineering and construction training, seeking to bridge the gap between engineering studies and the construction industry. Compressive strength of concrete.
IS 516-1959. Aim. The main aim is to determine the compressive strength of concrete cubes. Definition. Compressive strength, the resistance of a material to breaking under compression. Compressive strength is maximum load by cross-sectional area. Compressive strength of concrete. The compression strength of concrete is a measure of the concrete's ability to resist loads which tend to compress it. Apparatus. Testing machine. Cube molds of size 15 by 15 by 15 centimeters. Cylindrical mold of size 150 mm diameter and 300 mm height. Weights and weighing devices. Tools and containers for mixing or concrete mixer. Tampering rod, 16 mm in diameter and 600 mm length. Procedure. Sampling of materials. Samples of aggregates for each batch of concrete shall be of the desired grading and shall be in an air-dried condition. The cement samples, on arrival at the laboratory, shall be thoroughly mixed dry either by hand or in a suitable mixer in such a manner as to ensure the greatest possible blending and uniformity in the material. Proportioning. The proportions of the materials, including water, in concrete mixes used for determining the suitability of the materials available. Weighing. The quantities of cement, each size of aggregate, and water for each batch shall be determined by weight, to an accuracy of 0.1% of the total weight of the batch. Mixing concrete. The concrete shall be mixed by hand, or preferably, in a laboratory batch mixer, in such a manner as to avoid loss of water or other materials. Mold. Test specimens cubical and shape shall be 15 by 15 by 15 centimeters. If the largest nominal size of the aggregate does not exceed 2 centimeters, 10 cm cubes may be used as an alternative. Cylindrical test specimens shall have a length equal to twice the diameter. Compacting. Pour the concrete into the mold in 3 layers, each approximately 1/3 the volume of the mold, and rod each layer with 25 strokes of the tamping rod. Uniformly distribute the strokes over the cross-section of each layer. Curing. The test specimens shall be stored in a place, free from vibration, in moist air of at least 90% relative humidity and at a temperature of 27 degrees ± 2 degrees Celsius for 24 hours ± ½ hour from the time of addition of water to the dry ingredients, and places the cubes in water tank for 7 and 28 days. Placing the specimen in the testing machine. The bearing surfaces of the testing machine shall be wiped clean and any loose sand or other material removed from the surfaces of the specimen which are to be in contact with the compression platens. In the case of cubes, the specimen shall be placed in the machine in such a manner that the load shall be applied to opposite sides of the cubes as cast, that is, not to the top and bottom. The axis of the specimen shall be carefully aligned with the center of thrust of the spherically seated platen. The load shall be applied without shock and increased continuously at a rate of approximately 140 kg per centimeter square per minute until the resistance of the specimen to the increasing load breaks down and no greater load can be sustained. The maximum load applied to the specimen shall then be recorded. Observation.
After preparing cubes and placing them for curing, calculate the compressive strength by performing test for each cube for 7 days and 28 days and repeat the test for another 2 cubes and find the average compressive strength and note down the values as shown in tabular column.
Result. Concrete compressive strength for general construction varies from 15 MPa to 30 MPa and higher in commercial and industrial structures. Thank you for your time. If you have any queries, do not hesitate to contact us.